All right, consider the data below. Month, comma, year, number of Android apps in thousands. If you have it already written down, great. If not, fine. But what I need everyone to do is understand X is the number of months since December 2008. So I need everyone to figure out what those X values are for those months. For instance, March 2009 is 3 months after December 2008, so March 2009 represents 3. So if you would, figure out what all these X's are for those months. Good thing we're not going by the Roman calendar that had 13 months. I think it was the Roman calendar. So what do you get? So as we said, March 2009 is really 3. What's December 2009? 12. August 2010? 21. No, 20. August is the 8th month. May 2011. Oh my gosh, it hurts. Oh, it's 29, yeah. Yeah. July 2011. What'd you get? June, July, yeah. And October? 34. Good. Sorry if that's hard to read. All right, so what we're going to do is we're going to use our handy-dandy calculator to figure out the exponential equation, the exponential regression equation. So this is just like our linear regression equation that we did way back when in chapter 1 when you guys were this tall and very cute. When you were this tall and very cute, or chapter 1?
Both happening simultaneously.
I have photos. Okay. First thing we got to do is get the data into your calculator. You want to hit Stat, Edit. Now I have some stuff in there from some previously awesome work. You may as well. Stat, Edit. Yeah. You want to be looking at the L1 and L2 columns. If you have numbers in your L1 column, scroll up to the top until L1 is highlighted. Hit Clear and hit Enter. And do the same thing for L2. Scroll up to the top, hit Clear, and then hit Enter. Your L1 will represent your month years, so that'll be 3, 12, 20. How awesome if these were lottery numbers for tonight. And your L2 would be the number of Android apps in thousands. So since it's in thousands, we'll have to know that when we interpret this later on to say in thousands.
Couldn't we just put them in thousands in the calculator?
Yes, but that's going to make the numbers a lot bigger in the calculator.
All right.
Where it might have to make it exponential notation, scientific notation, depending on how big it is.
Oh, okay.
So it's best to keep it as in thousands. And besides, that's how the numbers were presented to me in the data. So it may not be exactly 2,000. It might be like 224.85.
Right, okay.
So it's best just leave it as it is. All right, we good? Okay. So once you have your values in, please make sure that they're all good to go. No, it's not going to affect it. Because the calculator will call upon the L1 and L2 columns by default. But if you want to call upon L3, you'd have to tell it. So we're going to do second quit. Ignore that, because that's the answer. Anyways, you want to go to Stat again. Scroll over once to Calc. And you're going to scroll down or up, your choice, until you see EXP-Reg, Exponential Regression. EXP-Reg. And you basically hit enter twice. Depending on the data, it may take some time. Again, you might only have an R. You may not have the R and the R squared. The whole purpose of the R and the R squared is to say how good of a fit it is. The closer those numbers are to 1, the better the fit. So 0.96 and 0.98, we're pretty good. So let's round this to, let's say 4 decimal places. So notice the format is y equals a times b to the x. So a is like the coefficient, b is the base in this case. So I can't memorize those numbers, so I'm going to ask you that you guys do that for me. Find the exponential regression that fits the data. You're going to say y equals, what was our a value? 2.0089. That was the 2 point? Was a? Oh, I'm sorry. Okay, 2.0089 times b, which was raised to the x. Is that okay?
I didn't get an R2 or R1.
Which is fine. As long as you got this A and B, you're fine. Yeah.
Couldn't you use just a regular linear regression like we learned in chapter 1 for this too?
Well, the thing is, if we actually looked at the data, it has a slight curve for it. So an exponential is going to curve like that,
Yeah.
whereas a linear is going to miss all these points because of the curve. So linear may not be a good predictor of the data, where exponential is a little bit better.
Okay.
Is that okay? That's a good question.
Hitting every point, if that equation hitting every point is it perfect? Why is there an R and
If the R and the R squared were 1, then it is perfect. But it's 0.96, so it's going to be off a little bit. I can show you the data and the equation on the calculator. You don't have to worry about that for my purpose.
everything that's straight? You said the average whole point, like you would say, like a linear
Right.
regression is a straight line that's going to miss the points.
Yeah.
But if you have a line like this, it's curved, so it's going to hit every point.
Right. I think it's going to come a little bit closer than a linear. Yeah. It's really honestly problem by problem. So for one problem, linear might be good. For another, exponential might be better. Part B, how many apps will there be in November 2011? Well, November 2011 is how many months since December 2008? 35. So you're just going to put in 35 in for X. Now, since we truncated our answer in part A, i.e. we rounded it, you'd have to type this in manually. If we did not truncate it, then you can have the calculator do it all in one fell swoop. Wah, wah.
Yeah, 531.8594.
Did anyone else get that? 531.89?
8594.
I'm sorry, 89.
8594.
Oh, 85. I apologize. And that's in what units? Thousands. So in 1 month's time, from October 2011, there's going to be 180,000 more apps. That's crazy. All right. Part C, when will there be 500,000 apps in the Android App Store? Well, this problem is sort of bunk now because Someone didn't check Part B's answer, this guy. So let's change that. Instead of 500,000, let's change it to 1,000,000. Huh? No.
And in these sort of equations, we'll always assume that it'll continue at the same rate of growth.
Yes.
We're going to assume that people won't stop making apps or
Cool.
people all die.
Right. So yeah, if it's a population, then yeah, you assume that no horrific thing is going to happen, where the population greatly decreases. Yeah. That's the only bad thing about them is... Yeah. Right. All right. To do Part C algebraically, well, we can't do that yet. That's what the next section's all about. So for right now, we can only do it using the calculator. So what we're going to do is we're going to graph the equation that we got from Part A. And we're also going to graph the horizontal line y equals 1,000. Why am I only saying 1,000? Why aren't I saying 1,000,000? One more time? Because we're already doing it in thousands, correct. So 1,000 thousands is 1,000,000. So we're going to graph both of those and see where they intersect. So in your calculator, you want to go to y equals. I'm clearing out what I have there in y1. You don't have to if you don't want to. Just turn it off, though. So in y1, I'm putting my exponential equation. And in y2, I'm putting 1,000 to represent 1,000,000. Do not hit graph just yet. Okay. As for the window, well, time can't be negative. So we're going to say from 0 to, let's just say 40. So that means we're starting at December 2008 all the way to, approximately. As far as the scale, let's make the scale 5. So that means every 5 units it makes a tick mark. As for the y's are concerned, since we want to make sure we hit 1,000, let's center it around 1,000. So let's say 900 to 1,100. You can make the scale whatever you want. You can just say 100. And now you want to hit graph. So pretty soon should come the exponential function. Anytime now. Bam. And double bam. We just made it. So we have to figure out where these two intersect. To figure out where they intersect, we're going to go to second calc. Calc is above trace. And you're going to select number 5, which is intersect. It's going to ask you for 3 things: first curve, second curve, and guess. We only have 2 curves on our window, so for first curve, just hit enter. For second curve, just hit enter. Now, if you had more than 2 curves, you would have to designate which ones you want to look at for the intersection. And as far as the guess is concerned, just put your cursor close to it if you want to, and then hit enter. Notice you get 38.96, yada, yada. Do not round that to 39, because that changes the month. Instead, just start it with the word during. So 38 months after December 28th would be what? Oh, gosh. Yeah, you're right, February. So February 2012. So you would say during February 2012, there will be 1,000,000 apps in the App Store. Now, since it's 0.96, it's towards the end there, but it doesn't matter. So, I think it's February.
March is 38, but February is 38.
Well, if October is 34, then November is 35, December is 36, January is 37, and February is 38.
Yeah.
So since it's 38 point something.
So the next go into March.
No.
I was translating.
If it hit 39, then that would be March. Yeah. Because by saying X is the number of months since December 2008, that means December 1st, not the end.